Hello everyone, welcome to the next stage of the challenge. Today we are going to see an example of how to do your first submission in the scoring platform in order to get the accuracy of your predictions. So as usual we are going to use Google Colab. I have loaded my data over here, the test and training folders, and also these two new files, the future description and the well location, which are already posted in the GitLab repository, so you can get them from here. Okay, so let's get started. First, we have to import some useful libraries, as you know. Then for the data loading, we have to define the path of these two folders. Why is this? Because we need to get the unique path of every single CSV file within these folders. Now you may be wondering why data is split in too many CSV files. So the main reason is that we are very interested to develop this contest as similar to real life as possible. So data structuring is one of the most important parts of this challenge. That's why we are going to work only with the high frequency data, and it will be your task to figure out how to handle the data structuring with the production data. Okay, so to do this we have to define a function that can help us to concatenate all these CSV files. So the one that we have here takes as an input the paths that we have set before and returns a concatenated data frame of all these CSV files. Okay, so once we do this, we can define the data frame for training data and a single data frame for testing data. So later we can get some information. So for training data we have 13 columns and more than 8 million observations. For testing data we have the same number of columns and also we have more than 1 million observations, right? Also we can see here that this little script returns the percentage of missing values per each one of these data frames. Okay, so if we take some samples we can get this. A very important clue from the data, as you might have noticed, is that pressure int and pressure int with K refer to the same thing, the intake pressure. However, this one refers only to the data that belongs to the year 2018, and it is the same for the intake temperature. So once we know this, we can merge these two columns and we can get rid of the useless ones later. So let's continue. Okay, let's get some data insights. So the first thing that we can find is that we have 100 train wells for training data and 15 wells for testing data. So another thing that we can find is the locations by means of this CSV file. So you may want to use this information for your missing value imputation or to find some patterns and some interesting things between the nearest neighbors and some other information. Okay, so that this can be very useful for your data structuring. Then we can get some statistics, and here we can find that we have outliers in the mean values and the max values per each one of these columns. So you must be careful at the moment of doing your data cleaning, because you may want to avoid feeding noise into your models. So keep that in mind. So you have to do some outlier removal and some data cleaning and all that stuff, right? So let's get some plots of this data. And since we already know that we have outliers in the data, we have this little script here which can handle that part. So if you take a look in this line, what we are doing to handle the part of the outliers, we just add and subtract a constant to the mean, and this constant is defined by 5 times the standard deviation of the same column. So when you do this, you are restricting the distribution of your data, and that can help us to get a better visualization of all the column. So this is just for visualization purposes. We are not doing any treatment to the data. So we can take a look of this current, future versus time, and frequency versus time, and discharge pressure. And notice a very important thing here, that even though that we have set these two limits, these lower and higher limits for the distribution of the data, we still have this outlier, and this is obviously lower than -2500. So you must be careful at the moment of doing your data treatment and your data cleaning with these values, because you need to avoid the feeding of the noise into your models, right? So let's continue, and we can get some other similar plots like this. And okay, you have a very interesting insight about vibration in your feature descriptions, so you may want to take a look on it. Okay, so let's do some missing value imputation. First, we can get some plots about missing values, and we can see here that these two columns are the ones with lowest data, so we can get rid of this, and also we can get rid of the output voltage for this exercise, and then we can define a function to do this missing value imputation. So for this example, we are going to use the standard methods of pandas, the forward fill and the backward fill. But remember that when you want to do this missing value imputation, you have to do before an extensive analysis of the correlations between the features and also the patterns of the data, the outlier removal, the data cleaning, and all that stuff. So for the sake of the exercise, let's continue, but remember that you may want not to do this missing value imputation in the simplest way. You have to do a very extensive job before to apply this, okay? And you have another ways to do the missing value imputation. You can use some machine learning models, or you can do a lot of things. And for the sake of the exercise, let's just apply the pandas methods, okay? So once we do the imputation, we can get this. So remember that we are not applying these methods for the target column, the whale failure, because we are looking for disruptive events, and we can't apply some backward fill or forward fill to the column that we are looking to predict, right? Then let's do some predictions. So for this example, I have chosen the model explainable boosting classifier. And as you might have noticed, we are dealing with an extremely imbalanced data set. So it will be very interesting to see what ideas and proposals you may have to solve this problem. So we have 111 outputs for more than 8 million observations in the training data. So that will be a very interesting problem, and or a very interesting challenge to overcome before you do your training. So keep that in mind. And for this exercise, we are just doing some shuffle and some oversampling to handle that part of the imbalanced data. And we do some pre-processing. We sort the data by date and the well ID, and then we set the date column as index in each one of these data frames. We apply the oversample method, and I have chosen 600,000 as the constant for this oversampling. And then we need to do the data splitting for X-train, Y-train, X-test. Then we have to define the model. So we have here, these are the features that we are going to fit into the model, and that's it. Let's do some predictions, and that will be everything to related with the part of the prediction. So notice one thing here. Due to the oversampling that I did here, now in the output we have an event failure per each one of these rows. So this is not what we are looking for, because you are not expecting, or we are not expecting, to have a whale failure every single row. So what I'm going to do here is to select randomly just one row per each one of the wells, and that will be this part of the script, right? So this could be my prediction for this exercise. And one important thing that you have to remember is that you have to keep the same order of the indexes. So you have to keep the order of the wells, and also you have to keep the order of the columns and the name of the columns. If not, you're going to get a score of minus 99. So if you get a score of minus 99, it means that your data either has a missing value or your data is not matching the index order, right? So you have to feed in the submission the well ID, the date, and the well failure. That will be your prediction for the submission. And one important thing that you need to keep in mind is that you have to save this output as predictions.csv. This is the name that you have to keep. And also, after you do that, you have to zip it, because the platform just takes zipped files, so you won't be able to upload any CSV file. Okay, so let's run this cell and let's download our prediction zip file here. Okay, and that's it. Let's do some submission. We have to go to Codalab. So you already have this link, so once you click on it, you are going to get here, and also you have to sign up and to put the name of your team and your nickname, and that's it. But remember that you have to put the name of your team, because that's very important for us because we need to do the final leaderboard, and we want to avoid these anonymous submittings. So please remember to put the name of your team. Okay, so once you're here, you have to join this e-challenge, platform, and then you can take a look at some of the details, but the part that you are interested in is this, in participate. So once you sign up, you can get here and click on submit in the competition. Okay, and well, you can see that I've been doing some trials to the platform to guarantee that it's going to work once you are using it. But it doesn't matter. I removed all these submissions from the leaderboard, so it's not important. Just please take a look on this. So once you have your prediction, you just have to click on submit, and then you have to upload your prediction zip file, and that's it. You can see that it says submitting. You just have to click on refresh status, and it's running, and once, yeah, we are done. So now we can go to the results tab, and here, oh sorry, I forgot. Okay, let's click on let's click on this. Let's see if it is updated. I think it's not. Let me see what's happening. So I set the maximum submissions for this time to 10 submissions. However, you are allowed to do just 4 submissions per each one of the members of your team. So for this time, you can see that I have 10 submissions, but when you are doing your submissions, remember that you just have 4 attempts per day. Okay, so let me see. I have this, and okay, I got it. So this is my successful submission. But what's happening here? The thing is that the algorithm is choosing the best score that you got. So for example, in this case is this 0.45. Okay, so the leaderboard is going to choose the best score that you have. So as you can see, I have uploaded my prediction right now, which is minus 1.8, but before I did another attempt and I got this score, right? So what you are going to see in the leaderboard is your best score. That's why I can see my last score right now here. Okay, so that will be everything for the part of the submission. We are eager to see all the ideas and proposals that you have for this challenge, and we are also planning some other events in this month. But remember that since we are in the stage of the competition, the only feedback that you are going to get will be after the deadline of this competition, not before, right? So good luck and take care. Bye bye.